Hey, what's up guys? In this video we're going to take a look at some more difficult examples of sums of cubes and how to factor them. Alright, here it is. Hey guys, in this one I'm going to assume that you're already pretty comfortable with how to factor a sum of cubes. And in this video we're just going to take a look at some more difficult examples and some special cases. So just a quick recap: if you have a sum of cubes where you have something like a raised to the third plus b raised to the third, then you can rewrite that in factored form, where we have a binomial a plus b times the trinomial a squared minus a times b plus b squared. And so what you want to do is figure out what a and b is in the first place, because this is written in terms of a and b, and then you can go ahead and just start plugging stuff in. So here we have a sum of cubes, sum meaning addition, and then cubes meaning this is a perfect cube and this is a perfect cube. And so when we want to factor this, the first thing we're going to do is figure out what a and b are. So a cubed is going to be 125k to the sixth. All right, and now we need to figure out what a is. So by taking the cube root of both sides, we can get a by itself. And so you have to think about what times itself again would give you 125k to the sixth. And that in this case is going to be 5, because 5 is the cube root of 125, right? 5 times 5 times 5 is 125. And the cube root of k to the sixth is k squared, because k squared times itself is k to the fourth, and then k to the fourth times another k squared is k to the sixth. Okay, so if you take this 5k squared and multiply it by itself, and then multiply that by another 5k squared, you end up with this here. So this is a, and now we're going to do the same thing but for b. We need to figure out what b is. So b cubed is 64 h to the third. And again, taking the cube root of both sides, you get b by itself. Oh, I'm sorry, h, not b. Oh wait, no. Yeah, I read that wrong. Okay, so this is b. By taking the cube root of both sides, you get b by itself. We're going to end up with 4h, because 4 times 4 times 4 is 64, and h times h times h is h to the third. So we have our a and b set up here. Okay, and now we can rewrite this in factored form by just making our substitutions. So we're going to start with the binomial a plus b. So a is 5k squared plus b, which is 4h. Okay, and now we're going to multiply that by the trinomial a squared. So I'm just going to plug stuff in for now. So we have a is 5k squared, and we're going to square that. Okay, minus a times b. Well, a is 5k squared. B is 4h. And then we are going to add b squared. So I should have given myself some more room here, but we're going to add b squared. Well, b is 4h, so 4h squared. Okay, and now we can just simplify. So we still have our binomial. And now this is where we can do our simplification. So 5k squared squared means 5k squared times itself. So that's going to be 25k to the fourth. All right. And then we're going to subtract a times b. So that's going to be 20k squared times h. And then finally we add 4h, the quantity squared, so 4h times itself, that's going to be 16h squared. All right, and here is your factored sum of cubes there. All right, so now we're going to take a look at some, that was just a more difficult one algebraically. Here we're going to take a look at some special cases, or a special case, should I say. Okay, so sum of cubes, x raised to the 9th plus y raised to the 9th. All right, so first and foremost, I want to figure out what a and b are. So again, a to the 3rd is x to the 9th. Okay, I want to know what a is. So I take the cube root of both sides. So you think about what times itself again would be x to the 9th. That's going to be x to the 3rd, because x to the 3rd times x to the 3rd is x to the 6th, and x to the 6th times another x to the 3rd is x to the 9th. Okay, b cubed is going to be y to the 9th, and similarly, that means b is going to equal y to the 3rd. All right, and now we'll go ahead and factor. So a plus b, a is x to the 3rd, b is y to the 3rd, and now our trinomial, a squared, so a is x to the 3rd, and we're squaring that, and then we subtract a times b, so a times b, and then we add to that b squared, so that's going to be y to the 3rd to the 2nd power. Now we can simplify that. So x to the 3rd squared is going to be x to the 6th. And then we have our y to the 6th there. So, at first glance, it looks like we have finally factored our sum of cubes into this expression here, but it turns out this is not fully factored, because what we've now created is another sum of cubes. This right here, this factor, x to the 3rd plus y to the 3rd, is a sum of cubes. This is a cube, we have a sum because we're adding, and here's another cube. So we can actually now factor this factor here. So what we're going to do is, again, decide what a and b are. Thankfully, this is pretty simple. So again, a to the 3rd, in this case, is x to the 3rd. Maybe we'll call this a sub 2, since we called that a. So a sub 2 to the 3rd is going to be x to the 3rd, which would make a sub 2 equal to x, right? Taking the cube root of both sides. And then b sub 2 to the 3rd, right, is going to be y to the 3rd, which would make b sub 2 equal to y. Okay, that's simple enough. And now we can factor this here. So we're going to have a plus b. So a plus b is x plus y. And then we have a squared. Well, a is just x, so a squared would be x squared. Minus a times b, and then we add to that b squared. Well, b is just y, so b squared. Okay, so this here is this factor factored, but now we have to recopy the second factor up here. All right, so now this here is your fully factored sum of cubes that we started with here. And here's the fully factored sum of cubes. Okay, so we'll do one more here. M to the 9th plus 1. So we will figure out what a and b are. So a to the third is m to the ninth in this case, and that would make a m to the third, because m to the third times m to the third times m to the third equals m to the ninth. And then b to the third is just going to be 1. And 1 is a perfect cube, because remember 1 times 1 times 1 is 1. So the cube root of 1 is simply 1. Okay, now we can go ahead and make our substitutions. So a plus b, and then we have a squared. So a squared is going to be m to the third squared minus a times b. A times b is just going to be m to the third. And then plus b squared, which is just going to be 1. All right, so we'll simplify this down. M to the third times itself is m to the sixth. All right, and now again it looks like we factored our sum of cubes, but now this here again is a sum of cubes. This factor m to the third plus 1 is a sum of cubes. So we'll figure out our a sub 2 here, right? So a sub 2 to the third equals m to the third, which would make a sub 2 equal m, taking the cube root of both sides. And then b sub 2 to the third is just going to be 1, which makes b sub 2 equal to 1. And now we will factor this factor here. So a plus b, that's going to be m plus 1. A squared, a is m, so a squared is m squared, minus ab would be m, plus b squared, that's just going to be 1. So this here is this factored, this sum of cubes is factored, but then we still have this factor here that we have to copy down. And this here is your fully factored sum of cubes. And with that said, it's been demonstrated.